Okay, let's unpack this. Imagine you're trying to hire uh, really skilled Oracle SQL developers.
Yeah.
Not just people who can write a basic select, but folks who really get the complexity, who can optimize, build robust stuff.
Right.
And as our source material for this deep dive points out, finding those people, it's genuinely tough.
It really is. And the cost of, well, getting it wrong, hiring someone who isn't quite up to snuff, that can show up in some painful ways.
Like what?
Oh, sluggish database performance, maybe security holes, projects grinding to a halt because the data side isn't working.
Yeah, that sounds bad.
It just underscores how critical it is, really, to have solid ways to check candidates out
Yeah.
when Oracle databases are in the mix.
Absolutely. So our mission today is to dive into this article, the one listing 30 tricky Oracle SQL interview questions. We want to pull out the key insights. What actually makes these questions tricky? Why would an interviewer even bother asking them?
Right. What's the payoff?
Exactly. And what can we learn by looking at some specific examples the article gives, covering theory, practical application, and those naughty real-world scenarios.
Right. The article does give us that nice structure, breaking down the question types. It's a great way to see how interviewers try to probe, different layers of someone's knowledge.
Perfect. So let's start right there. When this article calls an Oracle SQL question tricky, what does that actually mean? What sets them apart from, say, standard interview questions?
Well, the source defines tricky as questions designed to go beyond the surface level.
Okay.
They're tougher than average because they're really assessing the depth of understanding and the problem-solving skills you need for more senior or complex Oracle roles.
So not just checking if you memorize syntax.
Exactly. It's more about understanding the underlying principles and, importantly, how to apply them creatively.
Probing for true mastery, not just like familiarity.
Yeah.
And the article breaks these down into 3 main types.
That's right. First, you've got your theory-based questions. These test conceptual understanding, the why and the how. Think questions like, explain the benefits of X, or what's the difference between Y and Z?
Which often sounds simple, but can, reveal a pretty fundamental gap if you don't really get the concept.
Precisely. Then there are the practical knowledge questions.
Right.
These need the candidate to actually do something, write a specific query, maybe optimize some code. They usually start with write in SQL query to, or how would you make this query faster?
Where they have to translate a requirement directly into actual code.
Got it.
And the third type.
That's the case study or scenario-based questions. These are often the most challenging, I'd say.
How so?
They present a complex, sort of realistic problem, maybe navigating hierarchical data or dealing with tricky business logic or fixing a performance bottleneck.
Uh-huh.
And they ask the candidate how they'd approach it, how they'd solve it using SQL. It tests their problem-solving method just as much as their coding chops.
Okay, that framing makes a lot of sense. But why go to all this trouble? What are the specific benefits, according to the article, of using these kinds of tricky questions?
One of the biggest benefits mentioned is seeing a candidate's thought process.
Ah.
When they hit a tricky problem, one they might not have an immediate answer for, how do they react? Do they think methodically? Can they break the problem down? Do they ask clarifying questions?
Right.
It's often less about nailing the answer perfectly right there and more about watching how they try to figure it out.
Ah, so you're basically watching them think out loud, build the solution live. That tells you so much more than just confirming they know a command.
Exactly that. It helps verify skills that, look good on a resume. Anyone can list recursive CTEs or window functions, right?
Sure.
But a tricky question forces them to show they can actually apply them effectively. It's a way to cut through the buzzwords and see their real capabilities and maybe where they need development.
Yeah, I can definitely see how that would help filter candidates who might, let's say, inflate their experience a bit. What else?
Well, the interview setting itself gives you insights. How do they handle the pressure? Does a time limit fluster them? And critically, the questions they ask back can be incredibly revealing about their understanding and how engaged they are. Are they asking smart questions about the data model or the business need?
That's a great point. Their questions show how they're thinking about fitting the SQL into a bigger picture, into a real system. And didn't the article mention something about bias?
Yes, it did.
Yeah.
By focusing on objective demonstrations of skill and thought process through these specific technical challenges, The source suggests it can help reduce unconscious bias, the kind that might creep in during less structured chats or just from looking at a resume.
Yeah.
It gives you a more standardized, skill-focused way to compare candidates.
So using these structured, tricky questions helps paint a more objective picture of who can actually do the job, getting past just credentials or like superficial familiarity.
Yeah.
Okay, let's dive into some examples from the source. Maybe start with those theoretical ones where the nuance really matters.
Okay.
Mm.
A classic one,
Mm.
and one that really tests if you understand the subtle mechanics of analytic functions, is the difference between rank and denser rank.
Oh, yeah. They both assign ranks within a partition, but there's that crucial difference when you have ties, isn't there?
Absolutely crucial. Rank gives the same rank to ties, sure, but then it skips the next rank numbers. So if you have two people tied for second, the next rank is fourth.
All right.
Denser rank, though, it also gives the same rank to ties, but it doesn't skip any numbers. If two are tied for second, the very next rank is third, consecutive.
And that small difference can have a huge impact on how you interpret results, right? Like, if you're ranking competitors versus assigning tiers where every level needs a distinct consecutive number, getting that wrong could lead to totally incorrect analysis.
It's exactly right. Another fundamental theoretical distinction is between the where clause and the having clause.
Ah, this gets at the order of operations in SQL queries, yeah. Where filters individual rows before any grouping or aggregation happens.
Correct. And having filters groups after the group BY and the aggregation have already been done.
So trying to use where on an aggregate value won't work.
Right. Or using having on an individual row value before grouping. It's a common mistake. And it shows a gap in understanding the query processing pipeline. Plus, it can kill performance if you try to filter a massive data set after you aggregate instead of doing it before.
So knowing when to use, which isn't just about syntax, it's about efficiency too. What about something maybe related to best practices for applications interacting with the database?
Bind variables.
Yeah.
Definitely. The source emphasizes several benefits that go way beyond just writing the query itself.
Okay.
They significantly improve performance. Why? Because Oracle can cache and reuse the execution plan.
Ah, so it doesn't have to figure out a new plan every single time the query runs with slightly different values.
Precisely. It reduces that costly parsing overhead. Plus, they offer crucial protection against SQL injection attacks.
Because the values are handled separately from the command.
Exactly. The database treats them as data, not executable code. And they generally use less memory on the database server and need less maintenance in the application code. So asking about them tests if a candidate thinks about how SQL fits into the bigger picture, performance, security, maintainability.
That's a great example of testing knowledge that impacts the whole system, not just one query. And the article mentioned a very Oracle-specific nuance, too.
Yes, the age-old varchar versus varchar 2 discussion.
Right. Varchar 2 is the Oracle one you should generally use.
That's the recommendation. While varchar is in the SQL standard, varchar 2 is Oracle's implementation. And the key difference the article highlights is how they handle trailing spaces.
Ah, yes. Varchar 2 doesn't store them, does it?
It doesn't, which makes string comparisons reliable. Varchar, depending on the strict standard interpretation, though Oracle's varchar now behaves like varchar 2, could potentially store trailing spaces.
Leading to weird results in comparisons if you're not careful.
Exactly. ABC might not equal ABC. Understanding this shows a candidate knows those specific Oracle behaviors that can, bite you in subtle ways if you're unaware.
It's fascinating how these seemingly tiny distinctions can reveal a much deeper grasp of the platform. Okay, so moving from theory to actually, putting code on the page, let's look at some practical application examples from the source.
Sure. The article includes some straightforward ones, probably just to ensure the basics are covered, like finding the average salary by department.
Standard group by Y.
Yeah, a simple select departmented AVG salary from employees grouped by departmented. Confirms they can do fundamental aggregation, essential stuff.
For sure. But there was a slightly trickier practical example, the one about finding employees earning more than their managers. That needs a different kind of thinking about table relationships.
It does. It tests if they can use a self-join.
Joining a table to itself.
Right. To compare rows within that same table based on some relationship, like the employee-manager link, the query looks something like select E-employee name from employee E, join employee, M on N E manager equal M employed, where E salary, M salary.
So you treat the table as two different things in the same query, employees and managers.
Exactly. It shows they can conceptualize those different roles for the same data within one query. It's a common pattern, really.
Mastering self-joins is definitely key for many real-world data sets. What about practical tasks like, say, retrieving specific rows efficiently, like the top N or bottom N?
Yeah, the article shows how to get the last 10 logins for a user. It uses the modern efficient syntax that's in recent Oracle versions. Order by login deci fetch first 10 rows only.
Ah, the fetch first cause.
Right. This tests if a candidate is up to date with current best practices for limiting results, which is absolutely crucial for performance when you're dealing with large tables. Much better than older, clunkier methods.
That is a much cleaner syntax. Okay, so we've seen theory, we've seen practical coding examples. The final category was those scenario-based problems. These sound like the ones where candidates really have to combine multiple concepts.
They definitely do. A great example from the article is finding the longest reporting chain in an employee hierarchy.
Ooh, yeah. That's not something you can easily do with standard joins if the chain could be, like, arbitrarily deep.
Exactly. That immediately screams hierarchical data.
It does.
It tests if they understand how to navigate those tree-like structures.
Mm.
The article shows solving this using a with recursive common table expression, or CTE.
Recursive CTEs, powerful stuff.
Very powerful. Essential for problems involving parent-child relationships, traversing graphs, stuff like that. Seeing if someone can use them shows a pretty advanced level of SQL problem solving.
Definitely a sign of a more senior developer who's comfortable with complex data structures. What's another scenario example?
Identifying the author who has published the most books.
Okay. Seems straightforward, but probably involves a few steps.
It does. It requires joining authors and books tables, then grouping by author, counting the books for each author.
Use and count.
Right. And then ordering by that count, descending, and probably using fetch first one row only, or a similar technique to get just the top author.
So it tests their ability to assemble multiple standard SQL tools, joins, group by Y, aggregation, ordering, limiting to answer a specific business question.
Precisely. Applying several concepts together in a logical sequence. The article also includes simpler scenarios too, though, like finding employees eligible for promotion based on certain criteria.
Ah, the classic translate business rules into SQL.
Exactly. Translating rules into a where clause with multiple conditions, like select employer name from employees where years of experience EFI of 5 and performance rating equals 4. Just ensures they can apply basic logical filtering based on requirements.
And a practical data modification scenario. Changing data.
Updating salaries based on performance ratings. This tests the update statement, specifically using a where clause to make sure you only modify the right rows. For instance, update employees, set salary 1.05, where performance rating equal 5. It confirms they can safely and correctly modify data based on specific criteria. Don't want to accidentally give everyone a raise?
Oh, definitely not. These scenarios really highlight whether someone can take a real-world problem description and translate it into functional, correct SQL.
Yeah.
It's, like you said, more than just knowing commands. It's knowing how to structure a solution.
Absolutely.
Yeah.
And the article makes another crucial point. While these tricky SQL questions are incredibly valuable, they really should be part of a broader assessment strategy.
Right, not the only thing you rely on. Use multiple tools to get the full picture. What other assessment types does the source suggest combining these with?
Things like actual coding tests,
Yeah.
where candidates have to write and maybe debug SQL under some pressure, or even pair programming exercises. It also mentions maybe cognitive ability tests or personality assessments to get a fuller sense of a candidate's fit and potential beyond just their technical chops.
Yeah.
The main point is that while tricky SQL questions give you a really deep look at specific knowledge and problem solving, they're even more effective when you combine them with other methods that assess different facets of a candidate.
So these tricky questions are a powerful lens, a spotlight maybe, on their deep Oracle SQL skills and how they approach problems, but they're best used as part of a toolkit, not the only tool.
That's the key takeaway from the source, I think.
Okay, this deep dive into the article has been really insightful. We've explored the different kinds of tricky Oracle SQL questions, from those subtle theoretical nuances,
Like rank versus denser rank.
to practical coding tasks and those complex scenarios. We've also looked at why interviewers use them.
To reveal thought processes, verify skills beyond the resume, get behavioral insights, and hopefully contribute to more objective hiring.
And we walk through specific examples that where versus having distinction, the very real-world benefits of bind variables.
Navigating hierarchies with recursive CTEs, practical tasks like self-joins, efficient data retrieval with fetch first.
Understanding these questions really highlights the difference, doesn't it? Between someone who can just write basic SQL and someone who has that deeper knowledge, that problem-solving ability, and the platform-specific awareness needed for complex Oracle environments. You're assessing for mastery, not just basic functionality.
Yeah, it shows who can optimize, who can troubleshoot effectively, and who can think creatively within the constraints and capabilities of the database system itself.
Which leaves us with this final provocative thought for you, the listener, to consider. If these kinds of tricky questions are so effective at uncovering deep, nuanced understanding and problem-solving skills in SQL, how could similar approaches be applied to assess true expertise in other complex domains you encounter?
Right, whether that's other areas of software development or maybe data science or even fields totally outside technology.
Where are the tricky questions in your field that reveal real mastery versus just surface-level familiarity? Something to think about.